Okay, so we are given the following problem. Gaseous ethane reacts with gaseous dioxygen to produce gaseous carbon dioxide and gaseous water. What we're supposed to do with the given gram amounts of 13.8 grams of ethanol and 45.8 grams of dioxygen is we're going to calculate the theoretical yield of water, H2O, and with that information, we're supposed to find the percent yield of the entire equation thing. So, first off, here's our equation set up. We have ethanol, dioxygen, those are the reactants, and then they produce carbon dioxide and water. However, this equation is not balanced. This is the balanced equation. Each side has 12 molecules of hydrogen, 14 molecules of oxygen, and 4 molecules of carbon. We also need to find the molar mass of each of these compounds. Ethanol has a molar mass of 30.1 grams. Dioxygen has a molar mass of 32 grams. Carbon dioxide has a molar mass of 44 grams. And water has a molar mass of 18 grams. So, first, we are supposed to determine the theoretical yield of one of these questions, of a equation. We need to find out which one of the reactants is the limiting reactant of the equation, or the formula. And so that is between ethanol and dioxygen, and the theoretical yield we're trying to find is water. So we don't really need carbon dioxide throughout this whole thing. So to find that, we need to find the theoretical yield given by both dioxygen and ethanol to find out which one is the excess and which one is the limiting. So with that, we have to find the molar ratios between the two to work out both problems. Right now, we will start with ethanol. We'll keep that down there. This is the whole equation to finding the amount of water you get with the given amount of ethanol. The molar ratio between the two is that for every 2 molecules of ethanol, we produce 6 molecules of water. So we are given that in this question, we get 13.8 grams of ethanol. And that is equivalent to 0.46 moles of ethanol. To determine this, we just divide the given amount of ethanol, 13.8, by the molar mass of ethanol, which is 30.1. And this is, of course, equivalent to 0.46 moles of ethanol. And now that we have our molar amount of ethanol, we can determine what the molar amount we would get with water. So we take our molar amount of ethanol, 0.46 moles of C2H6, and we multiply that by the molar ratio between ethanol and water, which is for every 6 moles of water, there's 2 moles of ethanol. We take 0.46 and we multiply that by 6, and then we divide that amount by 2 to get 1.38 moles of water. Now, later on, we'll find out if this is the excess or the limiting reactant, because first we have to determine the amount we get with dioxygen. Now, with dioxygen, we go through the same process. We are given 45.8 grams of dioxygen, and dividing that by the molar amount of dioxygen, we understand that we get 1.43 moles of dioxygen. Now, with this 1.43 moles of dioxygen, we set up the molar ratio between dioxygen and water, which is for every 6 molecules of water, there's 7 molecules of dioxygen. So we take 1.43 and multiply that by 6, and then we take that amount and we divide it by 7. Now remember that, the moles of dioxygen cancel out because it's on the bottom. And with this, we understand that we accumulate 1.23 moles of water. Remember that with ethanol, we got 1.38 moles of water. Because dioxygen produced the less amount of moles of water, we can understand that dioxygen is in fact the limiting reactant. So now that we understand that dioxygen produces 1.23 moles of water, we can get rid of the equation here, we have to find out the theoretical yield in the amount of grams, because you can't find the theoretical yield in the amount of moles. Now to find the amount in grams, we take the amount of moles produced by dioxygen, 1.23. We multiply that by the molar mass of water, which is 18. In this case, we have 18.014, the more exact amount. We multiply 1.23 by 18.014, and then we divide that by 1. And given this, we get the answer that it produces 1.23 moles of water is equivalent to 22.16 grams of water. Now with this, we have our theoretical yield. In the question, it states that in our experimental yield, which is what we get through our experiment, we produce 14.2 grams of water. The theoretical yield in this is 22.16 grams of water. And now the final step is to just find the percent yield. And the formula for percent yield is taking the experimental yield, dividing that by the theoretical yield, and multiplying that by 100 to get the percent amount. The experimental yield is 14.2 grams. So we take 14.2 grams of water, and we divide that by the theoretical yield, which is 22.16 grams of water. 14.2 divided by 22.16 equals 0.641 others. And so multiplying that by 100, we get our percent, which is 64.1%. And that is our final answer.